Response of amphibians and reptiles to secondary succession in a tropical dry forest of Mexico, presented by Irelis Suazo, Javier Alvarado, and Jorge Marroquin. Secondary forests are in many regions replacing native tropical forests, one of the most threatened forest systems in the world. Secondary forests might play an important role in the conservation of tropical biodiversity. It is important to determine the potential of these secondary forests to support old-growth forest species, particularly threatened animal groups such as reptiles and amphibians. This study was conducted in the Chamela region and the Chamela-Cuixmala Biosphere Reserve, both located in the western coast of Jalisco, Mexico. Our study area is part of the Mexican Pacific lowlands, which is a hotspot of herpetofaunal species richness and endemism, supporting about 1/3 of the species of amphibious reptiles known in Mexico. To compare the structure and functional diversity of herpetofauna communities among successional stages, as well as the response of these communities to the cumulative effects of hurricanes, we conducted a long-term survey from 2009 to 2018 of frogs, lizards, and snakes within the successional stages. We selected a total of 15 1-hectare plots representing the following 5 successional vegetation stages: pasture, early forest, young forest, intermediate forest, and old-growth forest. There were 3 replicates for each vegetation successional stage. We registered about 4,800 individuals of 62 species of frogs and reptiles. In general, there was no linear correlation between animal abundance, diversity, and richness and successional stages for any faunal group. We observed lack of habitat specialization correlated with the existence of relatively low levels of beta diversity among forest successional stages, particularly when compared with beta diversity within stages. However, we found marked changes in estimated richness and composition of frogs, lizards, snakes among successional stages in response to Hurricane Hova. Modification in vegetation structure as a result of Hurricane Paz promoted particular changes in each successional stage and taxonomic group. Secondary forests at different stages of succession may attenuate the negative effects of an intense, short duration, and low frequency natural disturbance, such as Hurricane Hova, on successional herpetofaunal trajectories and species turnover. The cumulative effects of hurricanes might cause dramatic changes in the structure of biotic assemblages within hours of landing. Our results showed that accumulative effects of hurricanes, a low intensity and a high intensity hurricane, resulted in a homogenization tendency among successional stages, suggesting a negative effect for ecosystem functioning. We observed that under the impact of low-intensity hurricanes, successional stages might function as buffers that promote herpetofaunal resilience. However, cumulative effects of hurricanes resulted in a homogenization tendency among secondary successional stages, suggesting a negative effects for ecosystem functioning. The role of successional stages as promoters of the resilience of amphibians and reptiles is modulated by the type and intensity of disturbances.